Hello, nice to see you. It's like DevOps Days Toronto all over again.
Yeah, such a flashback.
Right? All right, I'll hand it over to you so you can get started. And yeah.
All right, fantastic. All right, well, welcome everybody. Hope you're all having a good day. My name's Andrew Kirkpatrick, and I'm here to talk to you today about self-service PR-based automated Terraform. So maintaining your whole infrastructure using Terraform and reusable modules makes most of our lives just that little bit easier. But when those less familiar with DevOps want to create or update resources, you usually either have to train and enable them to use Terraform or handle the request yourself. However, what if you could offload the execution of those changes to a centralized tool and just review both the code and output being submitted for review? So Atlantis, Terraform Cloud, or M0 can act as a PR-based feedback loop for a hosted Terraform executor to make self-service just that little bit easier. So infrastructure as code solves some problems, but not all problems. So any of us that have to respond to kind of access requests, change requests, any kind of sort of general service stuff, you get the feeling of like being constantly bugged, emails, tickets, Slack messages, what have you. And that's great and all, but is it actually important that someone with infrastructure expertise carry out a lot of these day-to-day toil type regular changes? And if it's not, what actually is important then? In that case, primarily, that those changes are performed safely and securely above all else. And then secondarily to that, make sure that they're tracked against, say, either what an individual wants, a team wants, or what can be attributed back to, say, a specific project that people are working on. Since it's infrastructure as code, making sure it's codified in a reproducible way, so meaning that you can tell what was changed by who and when and where. And then just like any other PR-based process, making sure that that's peer-reviewed and then approved by an appropriate chain of command, whether that be other team members, whether that be management, security professionals, or those with budgetary control. And why automate Terraform? So a lot of people that will be watching this are quite familiar with Terraform as something that we run day-to-day from our workstations, but why would we want to automate that somewhere else? So a lot of us, whether you use Terraform registry modules or you write modules in-house, a lot of that abstracts specific logic away from people and hides complexity. But kind of one of the differentiating factors, say, using internal modules is you can start abstracting domain-specific or business-specific logic into those modules to kind of conceal some of that complexity from some of your, say, internal teams. And then if you created these kind of pre-built internal building blocks, how easy would it be and how comfortable would you be letting other people kind of build their own infrastructure out of these Lego pieces, as it were, that you've kind of given to people? And if you did, how would you validate and approve that the things that they're trying to do are valid or correct? So a possible validation step is kind of akin to a Terraform plan. So I want to see what you're trying to do, and I want you to also be able to validate for your own purposes that what you're trying to do is actually what you think you're trying to do. Also importantly, make sure that those changes are revalidated. So if you've put up a PR, this is what I plan to do, it's not quite correct, needs some kind of mechanism that's built in to revalidate. If you say, in a PR context, push more commits up. So say, this isn't quite correct. Keep revalidating what I'm trying to do until I'm ready to do it. In terms of approval, essentially you can just piggyback on whatever kind of peer review process you use with version control. So if you have specific requirements or checks in place to make sure that people are reviewing certain things correctly, you can essentially just follow that exact same workflow. So if you want to have code owners for specific parts of your infrastructure, if you need to mandate, X, Y, and Z, all of that can work pretty much the same as any other process you've got on GitHub, GitLab, or Bitbucket. So what are we talking about today?
Sorry to interrupt you, Andrew. It looks like the slides, it looks like there's a little bit of like ghosting that's happening with them, and just want to give you a heads up.
Very strange. How's that looking?
Oh, perfect. Much better. Thank you so much. Sorry about that.
Cool. So yeah, kind of whistle-stop tour of the things that we're going to talk about. So dive in very briefly into how kind of you could rework Terraform a little bit, maybe for self-service purposes. How Atlantis, which we use at Partner Stack, compares to, say, Terraform Cloud or M0. How kind of a pull request workflow fits in to a Terraform, and then how that also works in kind of a centralized execution context. Some examples of how some of these things works, and then advantages and drawbacks of adopting a workload like this. Kind of looks like it's still happening. So keep going. So who typically develops with Terraform? So infrastructure engineers usually write infrastructure code, and application engineers normally work away on their applications. And that kind of typically results in an over-the-wall anti-pattern where like developers will like write applications, try and ship them over, and then do I need to quit and reshare? Yeah, can someone just double check that the slides are sharing correctly? Really can't tell.
Yeah, it seems like it's just having problems with repainting around the GIFs and the images, like when the slides change for some reason.
Give me one moment then, in that case.
No worries.
Oh dear. Alrighty. I think we're back. I think we're good.
Yeah, all looks good now. Thank you so much. Sorry about that, Andrew.
All right. Yeah, sorry about that, everyone. Firefox compatibilities. I blame that on. Back to Chrome. Alrighty. So who typically develops with Terraform? So kind of as I touched on, a lot of the times that results in a thrown over the wall anti-pattern in terms of like, I've developed this, I want you to make changes to this service, or like, I want these additional servers, I want to tweak to the database configuration, stuff like that. And there's kind of good reason for that, right? Writing Terraform from scratch is pretty daunting for people who've never done it before. Like a lot of us take for granted how HCL looks, but in a lot of cases, people find kind of the plethora of options and just the sheer amount of stuff available in documentation and in the public registry, kind of daunting. So could you kind of think, kind of counter to how some of the public modules that are out there, which are trying to simplify how you can roll out multiple resources, but how could you kind of conceal a lot of complexity away from some of the things that you roll out quite commonly within your infrastructure? So I kind of think of in terms of how can you apply guardrails to make sure that people don't do things that you don't want within the context of what they're trying to do or within your organization. So I break out configuration for modules in that case for in-house modules to be individually configurable. So just standard variable, this is what I want, dynamically configured. So kind of based on either say string interpolation, ternary statements, map lookups, like things that you can infer from other configurations that are specified. And things that are globally configured, say, this is what I want throughout my organization. They cannot change it, so it's always going to be this way. In terms of kind of how that actually looks, so let's say this is a reduction of a DigitalOcean droplet into, say, a module invocation. So I've kind of taken away a lot of the options that I want to be either consistent or things that I can calculate. And then how that translates back into the module. An example would be, I'm going to pick out the instance type based on kind of more simplified values for CPU and memory. I'm going to infer certain configuration options, such as like whether I want monitoring or backups enabled based on ternaries. And then say if I had complicated values, such as like VPC IDs or some kind of hash value that I don't want them to remember, I would say use a map lookup for that. And then just say whether it's in development or staging, we'll figure out the rest for you, just to kind of simplify it for them. So what options are there? Atlantis is the one that we use at my current job. I've used it for about 2 or 3 years now. But Terraform Cloud is like a very fully featured option, and M0 is a slightly different take on like kind of the Atlantis formula. So how do these compare? So Atlantis is, to my knowledge, one of the first applications to kind of do this. One of the main things that you have to bear in mind is that this is something you've got to host yourself. So it's a Go application, runs containerized. It responds to webhooks that are sent back from GitHub, GitLab, and Bitbucket. So that's kind of the only thing that comes into your infrastructure. And configuration can be pretty complex. So you can configure it for multiple repositories, different projects within that repository to execute. And you can be pretty flexible with the workflows that you apply to that. Terraform Cloud, on the other hand, runs either entirely in the cloud, entirely on-premise, or a hybrid with agent pools. You also get your own private Terraform module registry in there. So you can start splitting stuff out a little more kind of distributed that way. The enhanced backend for remote state allows you to do some pretty cool things, including remote operations. So run locally execute remotely. So that kind of works nicely with people being able to develop some stuff and then handing that off to then execute in Terraform Cloud later without ever actually running things on their workstations. And the concept of workspaces works slightly differently to traditional Terraform. So one of the benefits of using Terraform Cloud is there's a whole lot of other stuff that you can do in there, and there's a whole load of different workflows that are supported. So as well as PR-based, you can power this from an API, command line interface. The confirmation step actually also happens outside of, say, a version control system, even in a PR-based workflow. So there's a very nice interface to kind of show you who's applying what, who needs to confirm, who's applied. So the auditability of this is slightly better than the other two options. There are a lot of neat features that it supports. So preventing destroys might be something that's quite desirable, and hooks into other systems such as Slack. Like there's a lot more integrations that are available out of the box with relatively little effort. I haven't dipped into these options in particular, because originally I looked into this a few months ago. But there are lots of kind of different things that Terraform Cloud is coming up with to keep in line with Terraform development, which are pretty cool. In terms of some of the gotchas, one of the things I came across is that symlinks aren't necessarily supported. I think it's potentially how like your code is cloaked down. And one of the other gotchas related to that is it only supports, or last time it checked, it'll only support an enhanced backend. So if you're trying to use something in an S3 bucket or a GCS bucket, it won't work straight off the bat and treats it as net new. But the process to actually migrate state in there is actually pretty simple. It's just a gotcha to be aware of. M0, on the other hand, it's kind of, I would liken it to more on-demand type infrastructure. Well, that's kind of the way that it seems to be built and seems to be sold. So you create organization templates from version control from a repository. So like this is a master copy of a set of stuff that I want people to be able to deploy. And then you can deploy that out to kind of like 1 to n workspaces. So you then kind of create project environments based off a project template. And you kind of like just clone and clone and clone and clone. So a good example of this would be, say, if you want people to be able to have ad hoc developer environments, I think it's probably like a really good use case for this. It has native Terraform support for people who prefer that kind of workflow, and how custom you can get the workflow is pretty similar to Atlantis. You can do a lot of different stuff, and they have different language support if you want to get really funky with how that executes. In terms of the project templates, so you can kind of specify what branch you have in BCS to be monitored for pull requests against when you create an environment. You can also set specific destroy times, which is kind of handy. The environments themselves, you get kind of a nice interface that shows you like what has happened when deploys and redeploys have happened based on different triggering events, such as PR plans, stuff like that. As I mentioned, you can set time-limited environments to say, like, I want my development environment up for a day so I can quickly test this feature. So you can literally spin it up. It'll auto-destroy, which is quite nice. And then it has cost settings that are also built into that. So you can see like how much certain people are spending on certain things. And you can also limit how many environments they can spin up at any given time. In terms of the gotchas, state itself is managed entirely within M0, or it was the last time I tested it. So you can't kind of have a hybrid workflow between you developing locally and doing some of the stuff in M0. It kind of likes to manage that whole workflow end to end, which is fine. It's just you kind of have to be aware of that. And the whole thing kind of works off the concept of workspaces. So like it's very much like a 1 to n type system rather than specifically project and directory layout. In terms of configuration, there's pretty good support for all the kind of usual stuff that you'll have. The only additional thing that Atlantis can support, because it's self-hosted, is you can inject files and reference like any kind of file-based configuration you need to locally within an image. So if you need to build a custom image, mount config maps or secrets onto the container, stuff like that. In terms of an actual pull request workflow itself, so one common question is, why don't we use continuous integration for this? And that kind of breaks down for me into 3 kind of problem areas. Some of this is covered in Terraform documentation as a kind of like age-old problems of how do you synchronize plans and applies based on like commits, future commits? Do you discard? Do you keep going? How do you approve what someone has done, and how does that fit, say, into a deployment pipeline? And based on file changes, what are you actually going to like try and change? How do you figure that out? So it's kind of difficult to explain the plan and synchronization problem. So I kind of decided to draw a diagram for this presentation. So like if you were to put, say, something into a branch, whether it be main or a feature branch, if you did a Terraform plan off of that and then subsequent commits came in, do you then discard the older plan because you consider it to be out of date? And if you don't discard it and you then applied it, what if future commits came in? Do you then abort that apply because that's now based on out-of-date code in that branch? Or do you keep track of the plans? And if you had, say, multiple machines in a CI environment, do you copy these plans between things so they can be executed correctly? It's not a major problem. It's just something to be aware of. How this kind of happens with this, with these tools, is execution locking. So making sure that for a given project or workspace, depending on terminology, you can only do one set of things at each time, so everyone queues up to do their thing. So just to try and make sure that you kind of keep things consistent. In terms of how that looks in Atlantis itself, it actually locks the pull requests and then locks any kind of activity on it and will reference you to other pull requests that are stacked up in the queue and keep separate Atlantis locks in addition to Terraform state locks. In terms of actual approval, there are some CI tools that have manual approval steps, but do you want to essentially like hold on to a pipeline if you're waiting for approval? Because in the context of, say, a deployment, you'd probably be waiting minutes, maybe hours, but in terms of, say, an infrastructure change, you could be waiting hours or days. So it depends whether that really makes sense for something that's supposed to be short-lived. in say like CI runners. That's kind of a tricky thing. Like you could probably work something into Jenkins, but these tools, I would argue, have kind of a simpler way to do it in the context of PR. In terms of how that looks, say, in feedback, you essentially get the outputs of Terraform plans and Terraform applies with Atlantis and N0 posted back to the PR, so you can see it as just as if it was a terminal. And then Terraform Cloud and Atlantis both respond back to say, like, as a VCS status check to go, like, this is what I'm doing right now. You're either allowed or not allowed to proceed based on like what I've done in the background. In terms of reply requirements, like if you have specific requirements that you want to be in place for like pushing through PRs, then that's kind of like the workflow that's, like, say, we enforce in Atlantis. So if I want to make sure that this is approved by everyone I've said in GitHub can approve it, Atlantis will respect that and prevent you from applying things based on those requirements. In terms of centralized execution, where does the actual execution happen? So in a lot of cases, this either happens in the cloud or in your infrastructure, but in a central place. And that's kind of important to bear in mind because that determines how you issue credentials. So instead of different credentials for different providers being issued to individuals, say on platform team, infrastructure team, SREs, you're now issuing it to service accounts that are being dished out to a central place. And there are pros and cons to that. Of course, that can be desirable or not desirable, depending on how granular you want to be. But you then also have to think, I've got multiple providers now. Like, what permissions do I need to give specifically? You know, would I grant more or less permissions to a central executor that works on a PR basis that multiple people can access versus what I would give out to site reliability engineers? For example, you might not want that to be one-to-one. You might want to have that be a subset. That's just something to consider. In terms of how you map this is kind of like a simplistic example of, say, how I mount Atlantis configuration into Atlantis on the right, and then how I pass specific credentials on the left. Like, obviously, it's not how I would actually recommend you necessarily do it, but like there are good options for this, like Kubernetes external secrets, HashiCorp vaults. But there are various ways to get credentials into like a central executor, depending on which option you choose. In terms of execution, one thing that some people have is say, like, my workflow is not strictly just a planner apply. I do other things in between this step and that step. Like, I get custom tokens for this, or my token will expire in between a planner apply. How can I support that? Atlantis and M0 are slightly more customizable in that regard. Terraform Cloud, less so. That's kind of more of a stock standard Terraform experience, which is not necessarily a bad thing. It's just something to consider. So one of the weird workflows that I did for a job a little while back was we had a multi-factor authentication requirement to one of the roles that was actually tied to the service account. We didn't have time to refactor it out. So I essentially like used a Python script to generate a multi-factor key, pipe that back into a Terraform command, and then overrode AWS credentials to get that to happen. So I basically got it to pretend that it had a 2FA device. But you can do those kind of things if you want. Not that you should, but you can. So how does this actually look? I've talked an awful lot about stuff, but how does this kind of look in practicality? So say if I wanted to delete a DNS record, I would add that standard kind of get stuff, and I'm going to push that up and then create a pull request for it. So you can see the Atlantis UI on the left. I'm going to jump into GitHub here, create a pull request for it. And then the first thing that's going to happen is one of the checks will execute. Atlantis will try and plan it. It will comment back saying what it's going to do. So that's going to look like standard Terraform output. Yeah, okay, I want this record created. Great. Apply it for me. First thing it's going to do is reject it based on the apply requirements that we talked about. So it says, like, you can't do this. You need to go and get someone to approve it based on like your repository specific settings. Someone approves it. I comment back Atlantis apply. It applies for it. And then based on the repository configuration, I said, like, once all that's gone ahead, like, I've got Atlantis to merge it in, and then that will automatically that branch will get deleted. In terms of how the locking looks, so say we've got one PR on the left where someone's removed the record. In a subsequent branch that I'm going to push up on the right, I'm going to try and add it back. So we've now got two concurrent PRs trying to access the same project. So Atlantis has locked that for us. You can see we'll get back a comment, and that's reflected in the UI where it says, this is locked. This PR is ahead of yours, so they're either going to have to go first and apply their changes and close their PR, or they're going to have to discard, which is essentially like giving up their place in the queue to let you go first. They can then subsequently like replan and apply later. In terms of how this looks in M0, as I said, this is kind of me creating an environment based off a project template. So I've gone with an ad hoc workspace name. So this is just kind of creating another workspace kind of layered on top of this directory. But as mentioned, this is all kind of contained within M0. So like this kind of doesn't exist outside the context of M0. But my project template specifies that I want to create 2 buckets. It's just going to go through that and go, all right, I'm going to make 2 buckets for you. Good to go. In terms of how that works, it's always one video, it doesn't load. There we go. So let's kind of modify this in a feature branch. I decided my project environment would have like the target branch for this PR set as the watchable branch. So I'm going to set that as the base. I'm going to remove one of the things in there, put that up for PR. You'll see that M0 then comments back. And we'll say like, there's a PR plan in process. So you kind of flow through that. Similar kind of output. It'll comment back. Similar to Atlantis, this is what I plan to destroy based on the changes that you made. The main difference between Atlantis and M0 or Terraform Cloud is whether you do things pre or post merge, which is a preference thing. So this has said, all right, plan looks good. Your PR has been approved. Now that it's been merged, now I'm going to do stuff. Like this has an approval step within the UI, similar to Terraform Cloud. So I'm going to go and approve that. And then everything runs through. So those changes are in the branch that I had set to watch. That's all rolled out. In terms of how that looks in Terraform Cloud, relatively similar to M0, but more similar conceptually to how Atlantis works. So this operates on your repositories and state as it would normally. I'm just going to create these couple buckets. Confirmation step exists in the UI. Similar to M0, like you get linked out to their respective UIs from the PR by the feedback that you get on there. In terms of how it works with Terraform Cloud in the context of a PR, kind of similar. So we're going to commit changes back, delete this record, push that up. So like very rinse and repeat at this point, everything should look relatively familiar. The only difference is there's less information that Terraform Cloud pumps back into the GitHub UI itself. Only the status check will respond, but you then get kind of pushed back to here. This is what I'm going to do. Like need to make sure that this gets approved. All right, approved, good to go. Let's squash and merge that. That then gets detected in Terraform Cloud. You can go back to the runs and you'll see that it's like now planning, now that it's been merged into the branch that's been told to watch. Confirmation step as well, make sure that we're good to go. And then that gets rolled out. All right, so what are some of the advantages and drawbacks of using a system like this? So some of the advantages of if you've got people that need to do little pieces of infrastructure work from time to time, it means they don't have to get everything set up. They don't have to be issued credentials for each of these things. They can just clone the repository down, follow some basic instructions, put up a quick PR and get what they need to do occasionally done from time to time. It also means you get peer review before execution, which is kind of handy depending on your workflow. Because it's kind of VCS integrated, that potentially ties into other automation. So if you've got things that are tying into GitHub, GitLab, like plays quite nicely with that. It potentially simplifies what you're doing with credentials because you don't have to issue as many. Well, there's obviously a flip side to that. And depending on how well developed your peer review process is, it can potentially kind of alleviate a lot of the bottlenecks of, I need this stuff to be done. Let's just like keep throwing that over to, or keep getting this team to do it. So you can automate some of the toil away. But then subsequently, some of the disadvantages are you kind of saw the feedback cycle that you get versus developing locally is quite slow. So that means it's less ideal for developing modules or prototyping out some functionality. You might still want to do that locally, say like a platform or infrastructure engineer. Because you're moving the security controls from, say, your respective providers to your version control system, that's potentially an issue depending on how well developed that is or how complex you need that to be. And that then also means there's something somewhere, whether that be in your infrastructure or in the cloud, that has a bunch of credentials that allow you to access everything, which is more or less of a concern depending on how that plays out. If you're self-hosting it, it's something else you've got to maintain. And it can potentially be problematic if you're running on the same infrastructure as it controls. Like you destroy the thing that Atlantis is running on, for example, which I did once. So in summary, just to quickly wrap up, sorry for technical difficulties earlier. So Atlantis is open source and free to use. So that's one of the big benefits to it. And you can self-host it, very customizable. And that's a pro and a con to different people, right? So you can do a lot with it, but it's still something you're going to have to look after and babysit to make sure that it keeps working. One of the biggest benefits for me is that it does applies pre-merge. So that's one kind of mechanism that's nice to prevent potentially broken codes making its way into master. But I've spoken to other people that don't like it that way around. So that's very much a preference thing. M0, I think, is a really good solution for ad hoc infrastructure. Has a well-supported UI and workflow for that, and it's very customizable in terms of how that works and executes. Terraform Cloud, on the other hand, is, I think, the big bad enterprise solution. So there's so much more than what we talked about here that you can do with that solution. And even for in the context of PR-based workflows, provided you're doing something like more in line with standard, I think it's a very, very good solution for that. It's very clear what's going on. The auditability and practicality of a platform like that with all the integrations it's got is like far outclass as the other two, but for a lot of people, it's potentially like far more than they'll ever need and far more complicated than they'll ever need. So I think each one of them has their pros and cons and suits a potentially different use case. Thank you very much for listening. I'm Andrew Kirkpatrick. I work at PartnerStack. We're almost always hiring, as a shameless plug. But yeah, hopefully there's any questions I can respond to in comments. I went slightly over time due to my Firefox problems, so I apologize for that, but thank you.
Hey, Andrew, thank you so much for joining us today. It's great to see you. And I mean, is it really a live session if something doesn't go wrong during the stream? Unclear.
Right.
But yeah, I think we are out of time to do Q&A right now, but there is a couple questions, it looks like, in the YouTube chat. So if you're open to answering them there, we'd really appreciate that, and that'd be great. And yeah, thank you so much for joining us today.